Hello viewers, we are going to be solving this problem by method of mathematical induction. And in mathematical induction, we have three basic steps. The first step is to let n, or show that n equal to 1 or 2 depending on how you want to go about it. The second step, which is the induction step, is to assume that n equal to k. And the last but not the least step is to show that n equal to k plus 1. And so basically in mathematical induction, in the last step, we have to show that the left hand side is equal to the right hand side. And when we are able to show that, it means we've been able to prove that the equation is true for all natural numbers of n. So let's take the first step. So step 1, which is the basic step, we are to show that, or we are to make and say let n equal to 1. And so for the left hand side, since we have n here, for the left hand side we have n which is equal to 1. And for the right hand side, what we have is n into n plus 1 all over 2. So since n is equal to 1, here we have n into, we have 1 plus 1 divided by 2. This will be 1 into 1 plus 1 is 2 divided by 2. This will be equal to 1. So what we've seen now is that the left hand side, which is 1, is equal to the right hand side. So by implication, if you also make n to be equal to 2, you realize that your left hand side will be equal to 2 and your right hand side will be equal to 2, because 2 is the second term of this series. So let's go to step 2. So step 2, which is our induction stage, we want to assume that n equal to k. And so when we want to assume that, we have to get the entire expression we can call, or equation we can call this equation 1. So copying the equation 1, we have 1 plus 2 plus 3 plus, because we say n is equal to k, so we keep our k here equal to, we are done with the left hand side. Then the right hand side, we have n here, so we replace it using k into, we have another n, it will be k plus 1 bracket all over 2. So we are done with step 2. So in our step 3, we are to prove this assumption we made in step 2. So proving the assumption, we'll say that show that, this is step 3. So we say show, okay, let me use it, show that n equal to k plus 1. So basically what we do in this is to capture what we have from here to here, and then we add the k plus 1, because our n is now k plus 1, and then we consider the right hand side of the equation 2. So in doing that, you are going to take this, we capture this up to this point, so we are going to have 1 plus 2 plus 3 plus k plus, our n is k plus 1, so we have k plus 1 here equal to, coming here, and n is k, so we have k plus 1. Note you cover from here to here in the assumption stage first before you now introduce this. So we have n here, so we are going to have k into n here, we have k because n, okay, sorry, n is k plus 1, so it's going to be, the n here will be k plus 1 into, we have another n here who is going to be k plus 1, and then we have plus 1, and is all divided by 2. Okay, so we've gotten that, but you know that from here to this point is equal to this. And so we also know that from here to this point is equal to this. So we are going to bring in this value here to represent from here to this point, just that we've assumed that from here to this point is equal to this. So we are going to have k plus, k into k plus 1 divided by 2, which is representing from here to here. So we can now add this plus k plus 1 equal to k plus 1, the right hand side, into k plus 1. 1 plus 1 here will give us 2. So this becomes k plus 2. Of k plus 2 divided by 2. And so we continue our solution. Now, since we have 2 here, we can say take LCM. And so the LCM of 2 and 1 here will be 2. So we have 2 here. And so 2 into 2 here is 1. 2 multiplying the whole of this will give us k into k plus 1 plus 1 into here will give us 2. 2 multiplying the whole of this will give us 2 into k plus 1, which is still equal to k plus 1. We can put this in bracket into k plus 2 all over 2. Okay, so if you look at this, this is 2. Since here and here are the same, we can pick the outer one, k plus 2, and pick one of this. So we have k plus 2, which is this k plus 2. And since we have this and this to be the same, we can pick one. So we have k plus 1 divided by 2. This will be equal to k plus 1 into k plus 2, all divided by 2. And so, if you look at this, we have k plus 1, k plus 2 into k plus 1 divided by 2, k plus 1 into k plus 2 divided by 2. So, if you look at the left hand side, you'll notice that it is equal to the right hand side. And so, since that is true, we can now make this, we can now conclude and say, since the left hand side is equal to the right hand side, it's the mathematical statement is true. So it means this mathematical statement or equation is true, since we've been able to prove in step 3 to show that the left hand side of this equation is equal to the right hand side. So viewers, basically this is how to go about proving a mathematical statement by method of mathematical induction. Thank you.